All right, let's talk about displaying data. So, if we have a statistical question, we use graphs and charts to better see a list of data points. So let's say we've got a lot of data, we've got a lot of numbers, or a lot of data points. Doesn't have to be numbers that we want to put in categories. So instead of just having a big long list, we can spot trends and get a bigger picture quicker if we display it. There are 8 common ways to display this data. There are more than that, but there's 8 that we're going to discuss today. Can you guess them? We've got some that you've spent a lot of time with in the past: bar graphs, line graphs, circle graphs, line plots. You may have done some. Pictographs, stem and leaf plot, which will be kind of a new concept for some of you. Box and whisker plots, which we'll discuss in detail in the next video. And then histograms. All right, so today's notes, you're just going to put the 8 down. Each has its own advantages and disadvantages. The simplest is the bar graph, or the double bar graph. So why don't you just quickly, in your notes, jot a bar graph. So in the bar graph, we know we have on the x coordinate, the horizontal axis, we have different categories. On this one, we have sports. And then on the y-axis, we have some numeric value, like number of students. This is a double bar graph because we have the boys separate from the girls. In your notes, you don't need to make this very detailed. Just a quick drawing would be fine. Why would we do this? We use this to show and compare data about different categories or groups. So each category or group is distinct and different than each other. So an example would be favorite sports, like we did. It could be anything that's categories. Okay, next, let's talk about pictographs. Looking at this pictograph, a picto has pictures. This one's by favorite colors. You can see it a key at the bottom. One crayon, not crown, one crayon represents 2 students. So the favorite colors is red. We got all these. Could we make this a bar graph? Of course we could. We use this to show and compare data about different categories or groups, just like a bar graph. But why this? Because it looks good. So if you look in a newspaper or magazine, a lot of times they'll have pictographs. USA Today always has these. Just looks better visually. So it could be any category: number of shirts, shoes, pants in a closet. Could be favorite colors. You don't want your numbers to get too big for this, or it gets kind of hard, unless you, in your key, it represents a million or a large number. But okay, so that's kind of like a bar graph. And you could make this like a bar. This one's not a bar as much because they kind of overlapped. Okay, then we have a line plot, which is also very similar. This is what a line plot could look like. Notice we have distinct categories again: running shoes, walking shoes, tennis shoes. And we have our x-axis here, but what we don't have is a y-axis. Okay, so it's used to show the frequency of data along a line. It's often a number line. This isn't a number line, but we could have how many times this week you went for a run. Then you could have 1, 2, 3, and each student could put an X on theirs going up and down. So it looks like it forms bars. It looks like a bar graph without a y-axis. What's the advantage to this? It's easy to make, and you can change the numbers quickly. So let's say you have one more student enter the room and they have tennis shoes on. You could just quickly put an X here. You don't have to make a whole new bar. All right, so that's a line plot. Okay, the next one is the line graph. And we're going to spend more time later in the week later in the year talking about this. Line graphs are used a lot in math. They're used to show how data changes over time. Time will almost always be the x-axis because they're continuous. Now this kind of has categories with Monday, Tuesday, Wednesday, but this is over time. So it could be week 1, week 2, week 3, and you can connect your dots as you go. These have distinct dots. Sometimes you have a continuous. Okay, so time will almost always be the x-axis, and then the y-axis has some kind of number value. Could be a percent, could be the temperature. This is growth of a tree over a year, would be an example. Here's your average daily temperature on different days. Okay, so you can really see trends with line graphs because you connect your dots. This is different than a bar graph. Bar graphs show categories, where line graphs show change over time. All right, next, a histogram. This is kind of a mix between a line graph and a bar graph. So histograms are a useful way to illustrate the frequency distribution of continuous data. It doesn't stop, but instead of having a line go, you have categories. So you have a range from 2.5 to 3, from 3 to 3.5, 3.5 to 4. Okay, so this shows the lung volume of year 11 students. So this is, this would be like a junior. What's their lung volume? So if someone measures at 3.6, they would go in this category here, but this range between 3.5 and 4. So you can see most juniors in high school, their lung can hold between 4 and 4.5 liters. Some people bigger than that, some people smaller than that. Okay, so you have a frequency as your y-axis. Your x-axis could be ranges, no gaps. That's a histogram. Okay, next you have a circle graph, also called a pie chart, also called a pie graph or a circle chart. You've seen these before. And this is comparing parts to a whole. You never have more than one circle. Okay, yes, it's a fraction, but you're never going to have a mixed fraction. This is the U.S. population by age, back in the year 2000. So you can see the biggest category by far are people, ooh, it's kind of hard to see with these colors, over 65. Is it? No, over 65 is this one, between 45 and 64. So it's used to compare parts of a group to a whole. It's great to use percentages for this. You can see this is about 35% or so. This would be about 20%. You can see all your percents. An example would be favorite subject of a group of students. Okay, so parts to a whole. So we can change it to fractions, sometimes decimals, but usually percents. It will all add up to 100%. Next, we have a stem and leaf plot. This really emphasizes place value. Okay, so over here you have your stem, and then over on the right side you have your leaf. Usually you have tens and ones, so usually you don't go over 100. You can, but this makes it easier. Stem represents 10 digits, leaves represent the ones. So here's one stem, 22, then 24, 25, 28, 30, 31, 33. So looking over at the right here, these were all your data points in order. Okay, so you could have just had one list written out, but this kind of simplifies it and lets you see it, really emphasizing the tens digit, so you can see how many fit into each category. If you count the leaves, you'll know how many data points there are. There are 12 leaves over here. So you have 12 data points total. So you can quickly see, okay, what was the smallest? It's going to be in the 20s, 22. What's the largest? 55. Which stem, which group of 10, which range has the most? Well, look in here, it's the 20s. You have a 22, 24, 25, and 28. Okay, so that's a stem and leaf plot. Where would we use these? Well, I like it when I'm trying to figure out all the prime numbers between 0 and 100. You could just make a stem and leaf, and you can see patterns that way, recognize place value. Okay, last we have box and whiskers. A box and whisker. So you have your box in the middle, which is the median 50%. You have your actual median here. But this let us see quartiles very easily. quartiles, meaning quarters. So you have your lowest quarter over here, your middle, second lowest, smaller, your larger quarter, and then your largest quartile. Okay, so down here we have our minimum value, whatever that might be, our maximum value over here. Our median value, we'll talk more about median next week. You do need to know median. Median would be the middle number of a group. Not the average, but the middle number in a group. Okay, so this is what a box and whisker plot might look like. Love box and whiskers. It's my favorite kind of data display. You can see for a lot of information. You can really see where people fit and groups fit into the whole. You can easily see the minimum and maximum, and you can see where the most people fit in the box. Okay, this is good with test data. You can see how the class does on a test, who does really well, who does really poorly, all those things, box and whisker plot. Okay, if you have the Alex program, here are some good topics you can work on today. Especially the stem and leaf would be good. Pictograph, you probably have already done. Histograms, work on those. Tomorrow we'll talk more about box and whiskers, so that's why I don't have it here. All right, I will talk to you later. Good job today.